that all these windows that I'm moving my cursor over, left, the bottom, and the rightmost two of these windows are your part of the views, and the central window would correspond to the editor view. So these are these all together, put together, would what constitute as a Java perspective. You could have different perspective. As you move to the last part of the demo that I'll show, where we develop our own plugin, you will be actually prompted. By default, it opens in the Java perspective. But when you move into the plugin development, you will be actually prompted by Eclipse that the current perspective is not conducive for doing development of plugin. Do you want to change the perspective? So we'll see that in a little while. So let's move on to the presentation, because I want to show the development of the simple Java program using SWT, and that will help me to show more of Eclipse plugin related features. So I'll just go back to the slide. Okay. Now SWT, or Standard Widget Toolkit. Now this is a GUI or GUI toolkit that was developed by IBM. This was done to overcome the performance reasons. There is a bit of a history to this. Initially, I'm talking of the time when Java version was less than 1.4. We had numerous Java GUI platform was hopelessly slow compared to what it is now. When you had to develop the rich client applications or the standalone applications, the performance of it compared to the native platform applications, it was terribly slow. And at the same time, IBM was also interested in developing an IDE which they wanted to use for as you know, probably IBM used to produce one of the most popular IDEs way back then called Visual Age for Java. I'm not sure how many of you have got chance to use it or work with it, but it was very powerful, very popular. It's just that it was a bit more memory intensive, and at times it was prone to crashes. But when it was up and working, it was very good platform for doing developments. At that time, IBM wanted to develop it in a GUI platform that is very close to the native look and feel, and also the performance. I've read some of the articles that IBM in those days was planning to develop a toolkit or the rich client application, which was very close to the way Microsoft's popular development environments was. But then again, these are hearsays and some of the articles that I've read. But never mind. But IBM was the first to experience all this slowness and decided that there is an acute need for a GUI toolkit which is very very close to, which produces widgets which are very close to native platform in look and feel. At the same time, it is very very low on performance overhead. So that is what led to the evolution of standard widget toolkits. Standard widget toolkit, as mentioned here, is an abstraction layer that delivers native widget functionality in an OS-independent manner. How it is done in an OS-independent manner, I'll touch upon it in a little while. It is a foundation for the entire Eclipse platform UI, no doubt about it. I'll show in subsequent slides how this has been done. It was developed by IBM to overcome AWT's LCD problem and performance problems. So let's briefly touch upon what is this LCD problem. LCD stands for least common denominator. So Java AWT or abstract window toolkit, the way it worked was it identified a common set of widgets that were available across platforms, and then there was a peer widget that was there in Java, mirroring the native widgets, and then the control used to be passed to the native widgets for rendering. Now, this really limited the visual appeal of the applications that was being developed in the Java AWT. And second of all, since there are for every widgets that was there, you used to have a peer controls, peer widgets. So there was a bit of memory overhead involved because of creation of those additional Java classes. The way SWT solves this problem is it builds a common layer. It builds a very thin common layer of Java code, and then whenever there is a need for rendering a widget, it immediately passes a control to the native widget wherever possible, and the native widget shows up. So there is a very little performance overhead in doing so. And for all native widgets, if you were to look under the hood of SWT code, it is available for free download. You can go to www.eclipse.org/SWT and find out more about the source code itself. If you look under the source code, you'll find a whole lot of actually, when you are prompted to download, you will have to download the SWT against that particular platform, Windows, Linux, and so on. So if you go to that particular platform's code and download it, you'll see a whole lot of Windows API source code also. The C and MFCs and C++, VC++ code. So why that is required is that there are a lot of JNI or the Java native interface code that is there. So the control passes to the native widget through these JNI calls. So that's really a small distraction from what we wanted to cover on SWT, but that's just for your information in case you're curious as to how the control is being passed to the native widgets. But you may be wondering, what if that particular control is not available in the platform that we are dealing with? So in such scenarios, the SWT layer for that particular platform would have an emulated code, so that will take care of producing that particular widget. For example, that I've listed here. The tree widget is native in Windows, but it is emulated under Linux. So SWT makes sure that whenever there is a native widget available, it immediately passes the control to the native widget, and whenever it is not there, it will emulate it. Now, how does that happen? because there is not one SWT jar that will work for all the platforms. There is SWT jars that are specific to a platform, and you will have to download that for building your SWT widgets. So let's see the demo of how to build an SWT code. Okay, now let's develop a Java application. So before that, I'll create a package. Let's call that test.package. Okay. Now new class. And I'll check public static void main, which means that I want to run produce a standalone Java program which can be run from the command line. So this window that in which the Java code appears is the editor window that I was talking of, that is part of the Java perspective. So each perspective would have an editor which has been customized to take care of the nuances of that particular perspective. So the Java perspective has a lot of customizations, a lot of Java specific enhancements that we'll see as we go ahead in typing the code. For instance, let's say I wanted to add a system node. See, all I did was I just typed this out and press Control Spacebar. You will have to remember this Control Spacebar shortcut because we will use that in a lot of places. So as I typed this out and pressed that, it just expanded that entire thing. There are a lot of other things that are there. I have to go into preferences. So there are a lot of code completions and few other enhancements that are linked to Java specific thing. Code templates, there are formatting that is listed here, organize imports and how you would want it. See, this is what I was planning to show you. So there are a lot of the control space that I was showing, that I was talking of. So this is where a lot of them have been listed. You can, in your spare time, go ahead and get into the details of it. So let's get on with the coding part. There are a few other things that I just wanted to show. Some of the common shortcuts that you'll use. Say I just want to comment this entire piece of code. Just press Control and /. and that particular piece of code will be commented. And if you want to remove that, you can just right click, Control-Shift/, and that will remove the code, the commented piece of code. Other than this, let's say I add a lot of unwanted imports. Sorry. So you can see an exclamation mark over these things, and you says the tooltip. This is never utilized. So there is a quick shortcut to get rid of all the unwanted imports. So what you can do is Control-Shift and O, and it just removes all those imports that are there, unwanted imports that are lying in the code. So that's one other handy shortcut for you. Now coming back to the code, I have just, in the interest of time, I have developed all these codes on the source code that I intend to do a demo of it. So I'll just overwrite this. So now you can see that I have intentionally made sure that all these errors are highlighted because I want to show a particular, I want to highlight an important concept. If you look at it, Eclipse has highlighted all those controls which start with or which are part of the org Eclipse SWT package. Now, why is that? Because this particular project doesn't have the necessary set of jars that are required to run this or use these set of widgets. So what is the way out? So just right click on the project properties, Java build path, and then go to libraries, add external jars. Go to I have downloaded, if you look at it, can you see this? I have highlighted a particular folder. This is what I downloaded from the Eclipse SWT website. If you see this, this is the SWT for Win32 and x86 platform. So if you want to download it for Linux and x86, there is a separate set of download for that. So now I'll just add SWT and I click OK. If you look at it, did you see all those errors disappear? So this is what I just wanted to highlight to you. I'll just briefly touch upon the code that is required, what each piece of line here talks of. But before that, let's just run it once, just to make sure that the code that we have written actually works. Okay, just displayed hello world button. When I clicked that, it became thanks for clicking me. Okay, so to briefly touch upon this SWT. Now, the core class of SWT is the display. It's, you can say, the mother of all classes. The start and it has to come into existence from the start, and it will be the last one to disappear in the code when the program exits. So display is that one big controlling class, and each window that you produce corresponds to shell. A display can have as many number of windows or frames, and each one of them corresponds to a shell in SWT parlance. And what basically I'm doing here is producing a window. The set text, basically when I run this, one more shortcut for running the program is Control F11. So if you look at it, the Hello World title is basically just this, the set text. The set bounds is basically restricting the window size. The set layout is you have different layout managers which arranges the widgets. Fill layout is the most simplest of the layout managers. What it basically does is, as and when you fill the window with the widgets, it will make sure that all of them have the same size, width, everything. Color is just a resource that in resource is a terminology that is used in SWT. So color is a resource that you are going to utilize for putting it in a particular color. Now, one of the things, I'm sure a lot of you would have, I'm just making this assumption, a lot of you might have been familiar with the Swing toolkit which comes with the JDK. One of the difference between the listeners that you would see in the Swing toolkit and the SWT is in a Swing toolkit you will probably use a very generic name for the action listeners. Say add mouse event listener or add action listener. But in SWT, that's one departure where you will see that the listeners and adapters are very named after that particular event that will happen. So the selection is nothing but the clicking event. You will see in the JFace code that if you click on that, you will see a double click listener or some other event specific things. So and one last thing that you would want to see is that there is an infinite event read and dispatch loop as and when which until this particular window is disposed of, it will just keep listening to the events and just immediately dispatch it to the interested parties who are who deal with it. So we have trapped only one particular event, and it will come to this particular thing. Else, it will what it will do. The default behavior is it will dispatch that event to the native widget. So this is a quick thing on the Hello or the SWT. SWT, how to develop an SWT program. One main thing that you will have to do is, unlike in Swing toolkits, you will have to dispose of each and every resource that you would have acquired, because they are all native resources and you would have to take care of disposing it off. So that is why this dispose method is there, and of course display.dispose, which will take care of disposing of every other resources that may have been indirectly consumed. Next, we'll move on to the the JFace part. So in the interest of time, I will just hurry this up a little.